Okay, so yesterday we started talking about quadratic formula. And so let's do one just to refresh our memories. Then we'll talk about imaginary numbers. Okay, so remember our quadratic formula. Let's write it one more time, because what can it hurt? So it is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So we're writing it down. Let me see if this helps. Better or worse? So remember, you want to be in standard form. So ax squared plus bx plus c equals 0. So if it doesn't equal 0, that's your first step. Move everything over to where it equals 0. So let's do one like regular. So let's say we have 5x squared minus 8x plus 2 equals 0. Okay. So just like yesterday, we'll list out what is A, B, and C. Caleb, if you want to move so you can see better, that's totally fine. You can move back here or wherever. I know that seat's kind of weird. So what is A in this problem? 5. Good. So A is what's in front of the x squared. What is B? Negative 8. And how about C? 2. Good. Any questions on getting those three numbers? Okay. So now we just plug them into the formula. So x equals, and it's negative b. So negative 8 plus or minus the square root . You can, yep. So negative 8 squared minus 4 times 5 times 2, all divided by 2 times 5. Okay. Any questions? Plugging it in. So now we just simplify each little piece. So we have a negative 8. What happens when you have two negatives? It's a positive. So positive 8 plus or minus the square root. Now remember, in our calculator, we're going to type just what's underneath the square root. Now this one's different than the ones we had yesterday because our b values were positive. So since it's a negative 8, you have to put that negative 8 in parentheses. Okay? If you don't, it doesn't square the negative and that throws your answer off. Oop. So negative 8 squared minus 4 times 5 times 2. And we get 24. Alright, so again, if it's a negative b, you want to put that in parentheses. All divided by 2 times 5. Good. Questions? Okay. So now remember, we could be done, but that all depends on the square root. So I have square root of 24. Is that a perfect square? No. But could I simplify square root of 24? Yeah. So we want to simplify it like what we did yesterday. So we put the little 24 in a bracket, and you can just do this off to the side. And so remember, we want to start with our prime numbers. Our first one is 2. Does 2 go into 24? Yeah. Yeah. How many times? Good. So 2 and 12. So now we're looking at 12. Does 2 go into 12? Yeah. How many times? Good. And then how about 6? Does 2 go into 6? Yeah. 3 times. And then what's special about 3? Good. It's prime. So we can do 3 and 1. Okay. Any questions on that? And if you were here yesterday, that's what we did. So let me know if you have questions on it. We'll do a couple more. So now remember, we're looking for pairs. So I have a pair of 2's. So that means a 2 is going to come out. But then I have a 2 and a 3 left. I can't pair them up, so they both have to stay inside. So then that becomes 2 square root of 6. Any questions on that part? Okay, so we did all of that to simplify that square root of 24. So now I'm going to take that 2 square root of 6 and put it where that square root of 24 is. So then that becomes 8 plus or minus 2 square root of 6 over 10. So I know that we haven't really done many operations with square roots, but hopefully you did last year. But the only thing that can change what's underneath the square root is breaking it down like this. So when we get that 6 is not going to change anymore. Okay? But if I look at all of my outside numbers, 8, 2, and 10, could I simplify those? Yes, because they're all even. But we can't simplify the 6 because it's inside. Okay? But we can simplify everything on the outside by 2. So 8 divided by 2 is 4. Plus or minus 2 divided by 2 is 1. You can write the 1. You don't have to write the 1. It's up to you. We'll put it there. And then the square root of 6 doesn't change. Because again, the only thing that can change that is breaking it down over here like we did. And then on the bottom, 10 divided by 2 is 5. So this is our final answer. And this is about as tough as they get, and only because it has more steps. So yesterday we just had like a couple steps, and there it was, but this is about as long as they'll be. Questions? Okay, so last week when we talked about, was it last week? Whenever. We talked about the graphs, and there was that one problem where it never crossed the x-axis, so it didn't have any zeros. But it still has to have some kind of solution because it's a problem and it's there. So those kind of solutions are called imaginary solutions. So that's what we're going to talk about now. So imaginary numbers. So let's quickly just draw 3 graphs here. So one of them, let's say, looks like this. One of them looks like this. And the other one looks like this. So if we look at the first one, how many times does it cross the x-axis? 2 times. So this one would have 2 real solutions. Okay. So they might be 3 and 5. Or they might be square root of 2 and square root of negative square root of 2. Or whatever. So they don't necessarily have to be whole numbers, but they are real numbers. Okay, like these answer that we got right here is a real answer. How about this second one? How many times does it cross the x-axis? 1. So this one have 1 real solution. Okay. And so that's called a double root. So maybe your answer is 3. So it's just 1 real solution, but it's called a double root because every quadratic has to have 2 answers. But if we look at this last one, how many times does it cross the x-axis? None. So it has 0 real solutions. But you might say, well, you literally just said it has to have 2. So it does have 2. They just aren't real. They are called imaginary. So it has 2 imaginary solutions. So an imaginary number is an I, and I equals the square root of -1. So if you type in the square root of -1 into your calculator, it says, oh, just kidding. Don't look at that. If you type in the square root of -1 in your calculator, it says non-real answer. Okay, and that's because it's not real, it's imaginary. Okay, just like if you had a little imaginary friend and you was tiny. Just like that. So it is an I. And the only thing you have to know in Math 2 is I equals -1. Okay, when you get to Math 3, you'll do a little bit more with them. But for us, all that's important is that I exists in the world. Okay? And it is the square root of -1. So if we had a problem, let's say like the square root of -25. Now again, if I type that in my calculator, I get an error. But what's the square root of 25? 5. So we already knew that. We talked about that yesterday. So it's just 5i. That's it. So when you have an I, all you're doing is you're just bringing out that -1. Okay. Questions. And that's really all we have to know, is that they're there. And that's why. Just bring out the I. Yep. That's it. Questions? Okay. Alright, let's do a quadratic formula where that has an I. So let's say we wanted to solve x squared plus 100 equals 0. Okay, so first we have to find A, B, and C. So what's our A? So 1, good. Remember, if there's nothing in front, there's always an invisible 1. But how about B? Good. There's not 1, so it's 0. Very good. So if you're missing a term, you put a 0 in its place. How about C? 100. Very good. Okay. So then we plug it in. So x equals -b, so -0, plus or minus the square root